Hi everybody. Today we're going to go over the study guide intervention. We're going to go over both sheets in the same video. So yeah, the first part is going to talk about arcs and chords and the idea of inscribed and circumscribed. And just to go over this, inscribed means something is drawn inside of something else. So for example, this quadrilateral RSVT would be considered to be inscribed within this circle, okay? And then the circle would be what we call circumscribed, which is around the other object. So you'd say this circle is circumscribed about the quadrilateral. Okay, pretty straightforward. There's an example here which you'll see on your own. I'm not going to go over that. But let's go right through the exercise. I'm not going to do all these. I'll do 2 or 3 of them, and then let you guys do the rest on your own. So here we go. Each regular polygon is inscribed in a circle. Determine the measure of each arc that corresponds to the side of the polygon. Okay, so let's go ahead and do the first one. So this is a hexagon. So I'm going to do a quick and dirty circle in a hexagon. So a hexagon has 6 sides. So 1, 2, 3, 4, 5, 6. Yeah, and that's regular. So this is obviously not drawn to scale, but these are all considered to be congruent. Okay. All right. Determine the measure of each arc that corresponds to the side of the bar. Okay, so what we need to do now is find out what the angle measure of these arcs would be. Because obviously they would all be the same, because think about it, all the corresponding chords are congruent. So if chords are congruent, their corresponding arcs are also congruent. All right? Okay, so let's think about this for a moment. What is the number of, let's look at the number of arcs that are created. So we should have 6, right? 1, 2, 3, 4, 5, 6. And they're all going to be the same. So how many arcs is 6? So we know there's 360 degrees total. Divide that by 6. So each arc would be the measure of 60 degrees. Yeah, there you go, 60 degrees. Let's do one more. Let's do pentagon. So we have a circle. We have a pentagon. There we go. Not perfect, but you get the idea. 1, 2, 3, 4, 5. There's 5 arcs that are all going to be the same because the corresponding chords are the same. So that means there's 5 of them. They're all congruent. So 360 divided by 5. Oh, what's that going to be? It's going to be, let's see, divided by 72, I believe. No, is that right? Yeah, 72. Yeah, okay, sorry. I totally brain fart there. So 72 degrees for each arc. 72 degrees. There we go. Let's use the rest of those. Pretty straightforward. Okay, down here, I'm only going to do one of these because these are really cool problems. I don't want to do all of it with you. Determine the measure of each arc of the circle circumscribed about the polygon. Ah, okay. So let's go ahead and do the first one. So determine them, and you'll notice when I'm doing these, there's not enough room to do this on the paper itself, so make sure you're using some scrap paper or your notebook, because there's no way you can fit it on these. It's kind of the one drawback to some of these exercises. Determine the measure of each arc of the circle circumscribed about the polygon. So each arc, interesting. Okay, so we're going to find the measurement of each of these arcs. Okay. All right. Well, what do we know about this shape here? This is one of those examples that's not very good because there's not really enough information to definitively say this is what we assume it is, but we're going to just assume it is because I'm going to go on a limb and say that they probably screwed this up. This is supposed to be a rectangle, I would assume, and that would mean that this is congruent to that and this is congruent to that, so we could assume that the diameter is going through that. Maybe I'm wrong, I don't think I am though. So if that is the case, that would mean this is a semicircle, which means these add up to 180 degrees. So we're going to go ahead and say 4x plus 2x equals 180 degrees. 6x equals 180 degrees. That's not 180, it's 10. 180 degrees. Divide by 6. And x would be equal to 30. But we're not done because we're solving for these values. So 4 times 30 would be 120 degrees. And 2 times 30 would be 60 degrees. And there you go. I'll let you do the rest of those on your own. I think they're pretty cool. Let me know if you think I made a mistake there. I'm curious. Let's go ahead and take a look at the other study guide intervention. Let me move this one out of the way. All right, so here, and again, this is what I like about these. They have a little kind of like a refresher at the start of it. It goes and tells us a little bit about diameters and chords. All right, pay attention to this stuff. It's pretty important. Let's go ahead and do some of these problems at the bottom. There's also an example here. Basically, this involves creating a right triangle using Pythagorean theorem. This was in the notes that we did earlier. All right, so I'll do a few of these. So let's go ahead and look at the example they have, or the exercise they have, rather. So we have the circle on the right, which is actually very similar to what we worked with in the the notes, rather. In circle P, CD, so CD is this chord here, is 24, and CY is 45. The measure of CY is 45. Okay? CY is 45. Find each measure. Okay. So AQ, we'll find the first one, I guess. AQ. All right. Again, I'm going to give you some more information because I don't think they really gave you enough here. You're going to assume that these two chords are going to be congruent, and that's really the only way we're going to be able to solve some of this information. So, okay, so we know that CD is 24, therefore AB is 24. Okay, if AB is 24 and this is perpendicular to it, that means it bisects it, which means AQ would be half of that, which would be 12. So AQ is 12. Let's see. Let's find a harder one. Let's find. QB, let's do an arc actually, so that's 12. So measure of arc dy. So okay, so we know that this was 45, and because this bisects the chord, it'll also bisect the corresponding arc. So if this is 45, that means this is 45, because the entire arc CD itself is bisected because it corresponds to the chord that is bisected. So that would be 45. Let's do one more. Let's do CD. Well, the whole thing would just be 90, right? So them together. 90. And I'll let you do the rest of that. But I didn't want to do too many of these because I wanted you to have a chance to do it yourself. All right, let's do the one on the bottom. Let's do one. I'll do one of these. And shift it over a little bit. Hold on. Make sure you can see all of it. There we go. All right, so in circle G, DG, which is this piece here, is equal to GU. Okay, so these are, again, that means these two chords are equidistant from the center. And in a circle or in congruent circles, two chords are congruent if and only if they're equidistant. So that means because they're both equidistant from the center, that means these two chords are congruent. Okay, that's important. That's how you can tell that, actually. All right, that's an important part. It's actually the top of the sheet too. If you want to, like right here when you're looking at this, that's the second piece of information they give us, which is very important. I don't know if I went over that in the notes. I don't think I did, so I'm glad I remembered that. Okay, so all right, so we know these are equidistant. Therefore, we know these chords are going to be congruent to one another. All right. We're also told that AC. Well, actually, I guess they already tell us that already. Oh well. All right. This is 3. That means this is 3. It looks like the radius of the circle is 5 from the looks of it. I'll go ahead and connect that. Why not? 5. All right. Let's do the first part. TU. So TU is here. We would just use Pythagorean theorem here, right? So we have a right triangle. We have one of the legs. We have the hypotenuse. So we can go ahead and do that. So number 10, we're going to have a squared plus b squared equals c squared. Our a is going to be 3, our b is going to be unknown, and our c will be 5. So we're going to have 3 squared plus b squared equals 5 squared. 3 squared is 9, plus b squared is b squared, plus 25. We're going to subtract 9 from both sides. We're going to get b squared is equal to 16. And we're going to square root both sides. And b will be equal to 4. Alright, so that is TU is 4. And again, I'll let you do the rest. I don't want to do all this with you. So, but if you have more questions, obviously let me know. Alright, so I hope that was helpful, guys. There's a lot to do on the study guide intervention here. And again, if you have any questions, just let me know and we'll figure it out. Alright, thanks.